Hi, I'm Adrian Cockcroft. Over the years, I've given a lot of talks on microservices and cloud architectures, and there are some ideas I always wanted to illustrate with a short animated sequence. So I've worked with a visual design team to come up with a series of animations, each illustrating a specific concept. So this talk's on the evolution of business logic, as we went from monoliths through microservices, and now we're looking at functions. Back about 10 years ago, we had monoliths, and when we tried to split them up, we found that it was a lot of hard work. The networks were too slow, the CPUs were too slow, and the messaging protocols we used were based on XML and SOAP, and they were heavyweight. So when we tried to split things up, we ended up with fairly large services which had a lot of functionality in them, and we had a relatively small number of monolithic services that we built out. Moving forward a bit, what we found was that CPUs got a lot faster, networks got a lot faster, and we moved to much more efficient protocols. So it's maybe 100 or 1,000 times more efficient now to make calls between services. That let us take our monolithic services and break them up into microservices. Those services form a fairly complex looking network with a lot of messages flowing backwards and forwards between them. You can see here a service network, a service mesh, where we go from the edge, we flow through many layers of services to reach, on the right-hand side, storage services and caches. Now we take that environment, we think about the way that these services are becoming more standardized. So rather than building all these services ourselves, we're starting to use off-the-shelf services that are scaled, they're highly available, and they come from AWS. So we have SQS, DynamoDB, Kinesis, SNS, and S3, and we feed them all from the API gateway. The microservices that we built in between these is where the business logic lives. So if we look at that business logic, that's the glue between the bricks. And we're now starting to split that glue up and form individual functions that are really just connecting these services. And I've drawn this grayed out because they're not actually running until there's some work for them to do. You get a request coming in on the gateway, and it gets routed through a few functions and finds its way to a particular set of services. By doing this, it's incredibly efficient in terms of runtime, because whenever the system is idle, it shuts down and costs nothing to run. Everything is always 100% utilized, and it turns out these functions we're writing are really short and easy to write, and it's very fast to develop these systems too. So we've seen over the last decade, really, moving from monoliths to maybe 5 years ago when microservices emerged, and right now we're starting to see functions pick up as a new paradigm for building new business logic. This month I'm going to talk about rapid development. There's a lot of discussion about whether we should be building things out of containers or out of serverless components. I think that we should be building things really quickly and building rapid prototypes with a serverless options, and then optimizing those by adding containers. So I'm going to use some examples and some analogies to try and explain the idea behind this. Let's assume that we're trying to build something like a toy spaceship. The problem we're trying to solve is to get a model spaceship built quickly and cheaply so our kids can go play with it. Now, the traditional development, you'd design a prototype, you'd figure out how to carve it from modeling clay, then you'd make molds of that, then you'd produce some injection molded parts, you'd assemble those parts, some kind of robot. Finally, you'd have a finished, nice looking toy, just what you wanted. But that takes a long time. So this is the problem with traditional development. There's this waterfall of stages you go through. And if you're building custom software and you really want to build something that has never been built before, then you have to go through, work through all these stages, and it can take months to get to a result. So what do I mean by rapid development? Well, think of a big bag of Lego bricks and the instructions. And then just in a few hours, you can build your own model spaceship. It might look something like this. It's a finished toy. If you look at it, it kind of looks like the spaceship you wanted, but it's a bit blocky looking. And the real thing here is it lacks fine detail. It's recognizable. It's not exactly what you asked for. And you had to change what you wanted to fit what you could build a little bit. But still, you can get to play with this. And the other thing is, instead of being a fixed design, it's easy to modify and extend. So you could add a few more bricks on, create a different tail, something like that. And then the other thing you can do is optimize it. say, okay, well, spaceships are supposed to have pointy bits on the front, and it's hard to make that with Lego bricks. So we'll take some of the Lego bricks and we'll replace them with a custom brick that is exactly the right shape. If you look at the way Lego works, in their own, in real Lego kits, they're starting to build more and more of these little custom bricks that just add the things you need to make it look a little bit more like what they were trying to model in the collection of bricks. So what we're really doing here is building a more specialized common component that we might use in several places, but which doesn't fit in the standard format of whatever the bricks are. If I compare the traditional way with rapid development, we're moving from a full custom design to something built out of pre-assembled bricks. We're moving from months of work to hours of work. The custom components in the traditional design might be fragile, might need to be debugged, integrated. It takes a while to be sure that everything fits together. Whereas with Lego bricks, we know they fit together. It's very easy and quick to plug them together, and they have very standard interfaces. We're really moving from a world where there's too many choices and you can spend a lot of time discussing how it should be done, to something where you fit requirements to the patterns available. And these constraints reduce debate, they speed up decision making. So a big piece of rapid development is just the extra constraints actually speed things up. It's not just that they make it harder to get things done, they actually make it faster to get things done. So if we take this back to software and think about when you should be using containers to build something and deploy it, and when you should be using a serverless architecture. It's really where I was kind of thinking to get into this whole discussion. You build custom code and services and deploy them as containers, or with serverless, you're building serverless events and functions. There's lots of choices of frameworks and API mechanisms with containers. Some of them work, some of them are reliable, some of them are old, some of them have been deprecated, we no longer use them. Some of the cool ones don't even work yet. It's a big, difficult problem trying to figure out what you should actually be doing in the container space. Whereas with serverless, they're pretty standard choices. You know what works within the limitations of what it actually does. But what we find, if you think about that custom component where I took a bunch of bricks and formed it into a custom Lego shape, that's kind of what you need to do if you've got something that doesn't fit properly into a serverless environment. You might want to have lower startup latency, you might have some long-running compute jobs, or have just predictable high traffic where you want to optimize for that. That's when you need to go off and optimize the thing that you rapidly put together with serverless and build it out of containers and build some new services and then glue those new bricks together using your serverless framework. So for serverless, we're really just combining together these building blocks. Obviously AWS Lambda, then the API gateway as a front end, things like the notification service and the queuing service, DynamoDB for the back end, and step functions as a way to put it all together into stateful workflows. I hope you found that interesting. Please let me know what you think via comments or Twitter at AdrianCO, and stay tuned for new stories. Thanks for watching.